So there are four main types of registers. You have memory address register. There is also memory buffer register. We have instructor register. There is also program counter. Now registers are interconnected by an internal bus or data path. So the flow of data during or along the central path is managed by the controller unit. So we can ask ourselves, what is the data, the status, or what is the purpose of those registers? So to answer this question, we look like new at how to first instruct a program. So the instruction cycle begins when an address stored in the PC is transferred along the processor's internal data bus into the memory address. So this memory address register is also a type of register. Like in the definition we said, a register is a small high-speed memory location used for temporary storage of data or control information. So this is represented by register transfer language. So this is the address. So the register transfer language is conscious way of describing the movement of information through the system. So from the PC to memory address register. We're going to start from the system to memory address register. So the register transfer language reads as follows. The contents of the program counter register replace contents of program address register program counter register, like that. So the language the register translator, the register transfer language statement we read as follows. The contents of the program counter register replace the contents of the program. So the memory address register provides the interface between the processor's internal bus and the external address bus. So once the internal instruction address is in the memory address register, that address is passed along the address bus to the main unit when is incremented. So know that a bus provides an electrical path to carry out information from one unit to another. So the register transfer language of incrementing the PC is the incrementation. You remember that thing when they brought it? Is just PC plus 1 equals PC. Increment 1. What does it mean? So PC now contains 0 plus 1 is equal to 1. The address of the next instruction, that is 5. So as the memory unit decodes the address on the address bar and the location the memory cell containing the instruction of the processor generates a red signal on the control bus. And now we have the instruction is now copied from the database and latched into the memory buffer register. This is memory buffer register, MBR and MAR. So memory buffer register is also integrated as follows. Memory buffer register can be combined by M into MAR, memory address register. So the contents of MAR provide the address of memory unit, whose replace that one, that one, that one, this time that, this time that. Okay, this one was encrypted inside. Provide an address M that is replaced with MBR, memory buffer register. So if you can understand the stuffs here, if you can understand the stuffs there, then you're great. You're great. Yeah. Okay, what I was trying to check. Okay. Okay. Now we have the CU, which is a control unit. I think that is the control unit there. We are trying to mean. Okay. So now the memory buffer register interfaces the processor's internal bus to the external data bus. So when the copy of instruction is buffered into the memory buffer register, the processor transfers the instruction along its data in the internal bus to the IR, which is the internal register. So at the beginning, when we are just checking on the registers, IR, we have these IRs, IR instruction register, not internal. You get. So internal register. Okay. With the internal register, this is instruction register. This is memory buffer register. Instruction register, control unit. This is the register transfer language. So this is opcode. Remember, we one time to say it about the buffer code. Arithmetic logical unit. This is a logical block which performs a limited number of arithmetic logical plus or minus arithmetic. You can do it arithmetically. Decoding the opcode move as a move data from memory into the register. Okay, thank you for watching. I think we should have to add on next time. We have to do that.